As I said, we are going to discuss how do we observe animals and how do we convert our observations into data. So basically do quantitative observations. So before we get into that, I'm going to take you through a crash course of 3 slides on ethology. Ethology is the science of studying animal behavior. So we ethologists, as I like to say, probe into private lives of animals. You could look at what they are doing, how they are doing things. And of course, now there are people who also study the behavior of plants and not just animals. And then at another level, interactions between plants and animals. And when we are doing this, are basically trying to address the question of how animals live and why they live the way they do. Now, if some of you think back and remember the lessons from your evolution course, I'm sure you would remember that we have talked about proximate and ultimate questions in evolution. So here again, the how questions are the proximate questions. And then while we are asking why they live the way they do, we are basically trying to understand the evolutionary reason behind behaviors, or as we call the life histories of organisms. So when you are looking at ethology, most often all studies in ethology begin with some curiosity question, leading to some hypothesis which the scientist might have about why the observation is the way it is. And then to address this question and test this hypothesis, we can design experiments or do observations. Now, when we have to do this, whether it's observations or experiments, we will interact with one or more model systems, which are the species of our interest. So basically, what I'm trying to say is you can begin with a very simple question, and eventually you can arrive at very interesting or deep answers. And ideally, in the best case scenario, these answers will lead you to newer questions. And that is how research in ethology will keep progressing. And of course, most of these questions that we ask on a regular work schedule in a lab is, you would see these come under the how or proximate questions. But then there are, of course, people trying to put pieces together eventually to answer some ultimate question of their interest. So let me begin with a very interesting story. This person on my slide is Nico Tinbergen. He's actually Nicolas Tinbergen, but he's better known as Nico. And he was one of the founders of this field of ethology. So the story goes like this, that Tinbergen was taking a walk in a meadow, and he noticed that the species of wasp known as a digger wasp, also known as bee wolves, which make nests in the ground. So there are holes in the ground, which if you go dig inside, then inside is the nest of the digger wasp. And the hole is very small, so the wasp can go in and out. Predators typically will not be able to go in. What Tinbergen observed was that in this meadow, there were many such holes, and there were many digger wasps which seemed to be zooming in and out of these holes. Now, he was struck by this because he started thinking that these wasps, they are going out and then they're coming back with food in their mouth and they're going straight to these holes. How do they know which hole is theirs? Imagine you are taking a walk in a corridor in a hotel or a hostel, whatever, and there are doors on both sides without numbers. Would you know which door to knock on if you did not know some marker? Either suppose you're visiting a friend and the friend has told you it is the third door on the right, then you can go knock on this door. If there are no labels on the door and you don't know which room your friend stays in, you are going there for the first time, you would think that all the doors look the same. So this was the situation that Tinbergen observed, that all the holes look the same. How do the wasps, these tiny insects, know where to go? So his question was, how do bee wolves find their nest entrance when they return with their prey? Now, Tinbergen thought about it and he thought, let's try and answer that question. So, when we are looking for navigation, when we want to go somewhere, we either use road signs or we use maps or we use traditionally compasses and the modern day compass, the Google map. So somebody tells us where to go. Who tells the wasps where to go? Can you tell me, if you have to go to a place, find somebody's house, or suppose even better, somebody is visiting you, how would you tell them how to reach your house? How would you say the landmark? Now, suppose I say my house is near whatever, the post office. Will they be able to just come and find my house? So you have to give them the address to begin with, right? The address and a landmark, and then maybe sometimes a little more because your post office is not your house and there might be 10 houses near the post office. So if you need to be more precise, what will you tell them? They have your address. They know it's somewhere near the post office. I come to
The
the post
house
office. Then
number
what?
or the flat number. The house number or the flat
Yeah,
number.
that is the address, right? But if I
Ma'am,
want to be very precise,
ma'am, I tell how my house looks like, means the color of the outer part.
okay, so some description. And sometimes we also say, tell people, go to the post office, take the first left, take the second right, right?
Yeah, it's basically like
More precise
explaining.
directions. That is what directions are all about. Okay. So based on this notion of how we find places, Tinbergen framed the hypothesis that wasps might be using landmarks to find their nests. So these beautiful wasps here are the beetles. You see here, this is just plain soil with a hole, and the bee wolf is approaching the hole. Here, the bee wolf is out busy foraging, and you can see it's coming back with a really big bee. That's why they are called bee wolves, because they hunt bees. So they are coming back with this huge prey, and they have to stuff it inside this hole. So Tinbergen's hypothesis was the use of landmarks, and he wanted to test this hypothesis. He noticed that there are a lot of these acorns lying around in the field. What he did was he took some acorns and put them in a circle around the nest hole. So he says, I am creating a very distinct pattern of landmarks. So this would be the landmark. It's a circle of acorns around the nest hole. And if the bee wolf is using this to find the nest, then I can change this and see if the bee wolf changes its behavior, right? So he observed also that when the bee wolf flies out, it takes a hovering flight around this hole and then goes off. When it comes back, it goes straight for the hole. So this is also one of the things that he thought was maybe it's actually making a mental map of the landmarks around the hole. And that is how it finds out where to go. So he made this acorn landmark and waited. Bee wolf flew out, flew back in, flew out, flew back in. This happened a few times. Then she shifted this landmark to a place near the hole, but without the hole in the middle or without any hole in the middle. So now here is the nest, and here is the landmark, which has no nest in the middle. And sure enough, the wasp did not fly here. It flew to the center of the landmark. So it went and tried to enter the hole in the middle of this ring of acorns. What do you think would happen next? Of course, there is no hole there. Any guesses? Hello?
Ma'am,
Yeah,
ma'am, the bee wolf will try to find the nest, but as there's no nest, it will hover around, and try to find if it's nearby.
Right. So it will not start digging another nest. It needs to find its nest where its offspring or its eggs or its babies are. So it goes there, does not find the nest, looking around a bit, and then it tries to rise up and follow, hover around to find where the nest is. And now, eventually, it finds the nest. So now, what Tinbergen wanted to be doubly sure that it is really this pattern of acorns that the bee wolf is looking for. So then, what he did was he put this triangle around the nest now, changing from the circle, and he made a circle of stones. So then, when the bee wolf came back, instead of going to where the acorns were, it went to where the circle was. And he said, it's not really the acorns which matter. It is the pattern in which the acorns are put out matters. So it's the landmark is not a ring of acorns. The landmark is a ring around the hole. This is a very simple experiment which a kid could do. But typically, we don't think about these. We look around, we see things, we don't try to investigate. But this is a classic textbook example of an experiment in ethology. So what did he learn? That he confirmed his hypothesis that digger wasps are indeed using landmarks to return to their nests. And moreover, the landmarks are not the items, but the pattern which is being used as the landmark. Just to let you know that Tinbergen shared the Nobel Prize in Physiology and Medicine with Carl von Frisch and Konrad Lorenz in 1973. And the three of these people together are known as the founders of the field of ethology. And this is the only time that somebody got this Nobel for a subject like ethology, which is far away from physiology and medicine. Carl von Frisch for discovering the honeybee dance language, and Konrad Lorenz because he discovered how babies, something called fixed action patterns and imprinting in offspring on their mother. So these are very detailed experiments, which I'm not going into, but really fun to read about. They're all simple, curiosity-driven experiments which people performed in their backyards and their gardens. Nothing fancy, no science laboratory, and eventually they finally ended up getting the Nobel Prize for this work. Coming back to animal behavior, it is essentially a continuous process. So for example, if you were to note down what I'm doing, I'm teaching a class. If you want to say, okay, look at the behavior of teaching a class more carefully, I'm moving my hands, I'm moving my head, I'm talking, I'm changing the slides, I'm doing a lot of things at the same time. So often behaviors are a combination of various gestures and postures and vocalizations, and nobody stops behaving until they're dead. So even sleeping is a behavior, right? Sometimes students come back and say, this animal was not doing anything. So I asked them, was the animal dead? Oh no, it was just sleeping. So just sleeping is a behavior. You don't, often we think that doing something very active and energy consuming is behavior, and resting and lazing and sleeping is not. But we have to understand that most often the major behaviors that animals show are in states of rest, because you cannot be active all the time. Not every species is a hummingbird. Now, I said that we are going to objectively study behavior and quantify behavior. Now, how do you quantify something which is continuous? You have to find ways in which you have to break this continuity. So we need to discretize behavior. Even when there is a continuous thing happening, you have to discretize it into smaller and smaller units and say, okay, 3 times of doing this and 1 time of doing this and 4 times of doing this. So break down continuous behavior into smaller events and then go and sample behavior. And sampling of behavior is something that we really need to think about and understand deeply. Because often people say, why do I need to sample? I can write down everything that the focal animal, the animal that I'm interested in. So I study dogs. So if my students say, I will write down everything that this dog is doing, how can you be sure that you have written down everything? Didn't you blink your eye? When you blinked, do you know what the dog was doing? When you are bending down to write, do you know what the dog flicked its tail? So it's not, so when you have a continuous process, it's never possible to enumerate. It's never possible to take down everything. And the human brain gets saturated. So eventually you anyway start missing things. So we say we sample behavior. I cannot follow an animal from its birth till its death 24/7 for every second. But I can take snapshots of behavior over time and collate this over individuals, over a large population, and understand patterns which are hidden in this continuous behavior. And understanding of these patterns are typically done through statistics. We don't just say, okay, I've plotted three behaviors. This bar looks taller than that, so this must be different. No, we only say this when we have statistics supporting our claim. If I say 5 is greater than 3, yes, mathematically it is, but statistically it might not be great enough to say that it's different. So this is why you really need to look at data, use statistics to look at the patterns that are underlying in the data. So when we talk about sampling methods, sampling could be quantitative, which is what I was saying, that we have to quantify, we have to discretize and then quantify, or it could be qualitative. Many classical studies in behavior and animal behavior and ecology were even earlier called natural history studies, where people just went out with field notebooks, wrote down whatever they saw. So Darwin is a classic example. He was not really sitting and quantifying things in the field. He was making observations, he was taking detailed notes, and later he brought these notes back and analyzed them, thought about them in much more detail. And then he took his stuffed birds to the museum, and there he went and did some measurements and comparisons. But most often he was doing qualitative observations, which we typically now call ad libitum observations. And this is what you are going to begin with. Quantitative observations broadly can be scans and all occurrences or focals, and this is something we are going to talk about in more detail in the next class.